Hello there, this is Billy. This is part 3 of my 3-part video to create this Ring Variometer Crystal radio. You can check out the link in my description to my post in the blog to get more information. After printing out the 3D model, you can start wiring using the list wire. So I'm using this 60 string list wires made up of tiny wires. You can wire it like this, and altogether you wind 60 turns with the tapping at the 5th turn and the 25th turn. So after finished wiring, it will become something like this. So the tapping points are created at the bottom like this using solder iron. You can use a very hot temperature like close to 300 degrees Celsius to solder another list wire on top of that tapping point. To avoid hurting the other wire, you have to put in some paper to insulate the heat. So after wiring this curved coil, make sure the coil is as close together as possible. Don't wind the coil like this, because it will decrease the Q value and reduce the range of the inductance between the minimum and the maximum inductance. So always keep your coil close together like this. After that, you have this ring and the core, the forward core. This is the one that I bought, which is already cut in half when I bought it. But in case you have the other ones that hasn't been cut, the forward core come in different sizes. This one is the smaller one, 37 millimeter diameter. This one is the bigger one, 45 millimeter diameter. And then this one is the bigger one, 42 millimeter but 15 millimeter thick. So some of them you can order that's already cut in half, and you can use it directly. But if you got the ones like I have that is one piece, you need to cut it at around 220 degrees. So don't cut in half, cut in 220 degrees. So you leave some more than half portion. So when it goes inside this core wiring frame, you will have enough portion that are already in to guide through the turn. Otherwise it will be very hard when you pull it completely out and try to get into the hole again. It will not be smooth. So always cut more than half. So there's already one part inserted into this wiring frame here. So how can you cut the ring in 220 degrees? If you got this type of small drills, you can fit a diamond coated blade, and you can just use it to cut like this. But you don't need to cut through the entire forward core, because it will take you a lot of time, maybe 10 minutes, 20 minutes. And then you will create a lot of dark powder that you need to clean up later. So I suggest you just cut in a circle, just cut a crack at the parameter, and you use a screwdriver and a hammer to bang it like this, and then the crack will be cracked open. If you don't have this drill and blade, what you can do is use the glass cutter. There is a small diamond blade here, so you can cut it like this several times, and then creating a crack that you can again use the screwdriver and hammer to cut through. After that, use the file to sand it out. Okay, so my ring is designed to tightly fit the ring already, but if you find that it's not tightly fit, just wire some tape and make it tightly fit like this. And then you can put the two together after wiring. Just slide it in like this. there's a hole inside this one. You can use a needle, try to be the pivot point and test whether it can turn properly. You can turn the ring and put it in properly. Okay, after that you can mount it on the baseboard. Then you can continue to do some other testing before you mount the rest of the components. If you have a Q meter, you can test the frequency range coverage, whether it fits with the AM radio. After assembling the forward core variometer, we can start installing the other components, which includes a pair of stands for fuse and a 4-pin socket for the 3DQ or MOSFET. So first let's take care of the socket first. We will need to cut off and leave only 4 pins. Okay, so you have to sacrifice 1 pin when you cut it, because otherwise you can't cut it cleanly. Okay. You may want to use plier to smooth out the edges. A bit like this. Okay, so the size should be able to fit within this. Okay, it's nice. So after assembling your variometer and install it on the baseboard, we now need to insert components to mount our detector. There's 2 ways of mounting a detector. You can use this type of fuse stand and put your diodes inside the fuse tube, like this one, and then mount it on. The other way is use this microcomputer sockets. You need 5 pins, the first 4 pins for the MOSFET, the last pin for the diode. So let me cut this one. To cut it, you have to sacrifice one of the pins, otherwise you will not be able to get the 5th pin. And you can use the pile to make it a little bit flat. Like this, and then you can insert it into the baseboard. Like this. Okay. For the fuse stand, there are 2 holes. You can just push it in like that. So after setting up your variometer onto the baseboard, you can start looking at the diode or the detector. So we have 2 ways to mount the detector. First way is to use this computer socket, 5 pin. Lower 4 pin is for the MOSFET, the 3DQ. The upper pin is for the diode. So you can mount it here like this. And then at the same time, if you want to use the fuse tube, you can use this type of fuse stand. You can buy the ones readily made, or You can buy this type of single stand. There are 2 holes you can drill onto the baseboard to mount this one. It can be mounted like this very easily. And then you can solder at the bottom. And then the second one, like this. So if you mount both this microcomputer stand, socket, and fuse tube, they can coexist nicely. So you can either select to use the fuse tube or your diode or crystal or the MOSFET. Let me show you how to insert the MOSFET. So this is the MOSFET. I usually solder this surface mounted device 3D onto a small perf board and then extend the legs from there into the 4-pin socket. The 4-pin can plug into this computer socket like this. Okay. And then the top pin can be used by diode as well. If you have a diode like this, like this one, and then you can insert it into the top pin and the middle pin like this. Okay, and then you can use your detector that way. To look nicer, you can put your diode inside a fuse tube like this one, but it's very hard to separate the cap from the fuse tube. I happen to have some QC failed fuse tube where this cap is glued into the glass tube, so I can just twist and take it out like that very easily. But if you can't find this type of QC failed fuse tube, the caps are very tightly sealed into the glass, so you can't take it out easily. No matter what I try, hot and cold method, it just happened to break the glass. I can't just take it out. So what do? I designed this 3D printed transparent PLA fuse tube that you can use to insert your diode. So just put a diode inside. Okay, when it's bend the legs like this, and then you can put the cap at the end. Like this. Just one more cap. Where is it? So you can put another cap here in the same way. Like this. Then you have a fuse tube for your diode, and you can easily insert it here. And you can easily insert it here. Okay, so this way you can use both the MOSFET and as well as this fuse tube as your detector. Finished assembling your variometer to the baseboard, you can start installing the other components. The first one is how to detect the audio signal. You use the detector. There are two types of detectors you can use. You can use the diode, like this one, or the MOSFET like this one. So the MOSFET is actually a very tiny surface-mounted device, 3SK143-Q. We call it 3DQ in China. It can be soldered into a small piece of perf board, and with the 4 wire extended to these 4 pins. I have the G2, D for drain, S for source, and then finally G1, gate number 1. So in order to allow either one of these to be used, in most of my crystal radio, I design a circuit so you can use either diode, crystal, or MOSFET of your choice. And to make it more flexible, we have a 5-pin socket here. It's a general computer socket you find in people doing the Arduino projects. So we just cut out from the original 8-pin or 16-pin and get 5 pins left. If you need to cut it out, you have to sacrifice the 6-pin. Otherwise, when you just cut on the 5-pin, it will become a 4-pin because the hole there will be broken. Just to be careful. So you can mount the 5-pin socket from the bottom and then screw it in like this. Then just leaving nothing extruding from the surface, and then you can insert your 3DQ like this, or your diode like this. Use the top pin and the middle pin. Right. So because of different impedance requirements, I make a special tap from the coil to the top pin, so this pin will be more suitable for use with the diode versus the MOSFET. Still, there's another way you can mount your diode or crystal and make it really cool. So it's by using this type of fuse. You can put the diode inside the fuse tube. If you happen to have some fuse tube that is loose enough, you can take off the cap. But I find that it's very, very hard to do that, so 3D printed semi-transparent fuse holder. So you can put your diode inside, bend the legs, and then you can break the glass and get the cap out of a fuse, and then put the cap, push it in. I've designed the fuse transparent tube such that it's loose enough for you to push the cap in without breaking or hurting yourself. So put both ends in like that. It will become a fuse tube with a diode, just like this one. Optionally, you can print some paper label and label it as the model number of your diode. So when you finish this one, you can insert the fuse stand like this. They're standalone fuse stands. You can use as your circuit board, or you can buy this type, which is already mounted on a small piece of board. So for my DIY project, I usually will choose the standalone one and just drill holes to mount it on my board like this. So this way you have a multifunctional, multi-purpose detector socket. You can use the fuse stand for your diode mounted on the fuse tube. For my projects, I prefer to use this type of standalone fuse stand. When you insert the fuse stand, make sure you take note that one end is closed, so it's different from the other end. So you will have to hold the fuse in place. So when you insert it, make sure That end is at the outermost there, right? Close to the edge of your board. Like this. And then the other end also. Put it like this. Okay. Now you can insert your fuse tip. Let me try this one. Like that. So it's so cool. You have a nice looking fuse holder that's also holding your detector. Next is to mount this band switch, a mini band switch, and we use this type of M2 screws to mount it. So there's a small opening here and two little holes. They've been designed to fit the holes of this switch. So we just need to put this M2 screws in. Okay, like this, and you can switch, band switch by your nail. Low band, high band. Okay. Then you need to insert the headphone jack. So try to find these small ones. 3.5 millimeter. We don't need this ring. Just need to put it in. Okay. Okay, like this. You can plug in your headphone to test. My earbud, you can use it to test. Is to solder the capacitor. We have 3 capacitors that we need to solder. First one is this 3.3 N, or you can see 3N3, which is 3300 PF. It is for smoothing out the audio at the headphone jack and getting rid of the high frequency. And then we have these 2 band capacitor. They are the fixed capacitor to pair up with our variometer, so we can tune to the high band or the low band of the AM radio. First one is 751. That means 750 PF. It's very hard to see, but you can see 751 somewhere on the label here. It's very hard to see. And then there is the 150. If you got 150, 200, 300, you can try those. I should use 300, but I don't have it, so I use 151. That means 150 PF. So this is 750 PF, 150 PF, but it's better to use 300, just half of this one. It depends on how many turns you have in the coil as well. So we just need to find a matching fixed capacitor value to match of the frequency of AM, which is from around 540 kHz all the way up to 1640 kHz. Next, we have to install the terminals for the antenna and the ground. So we use this type of connector plate to connect, and we'll insert it into the hole here. This is M4 screw because I'm using this type of telescopic antenna for use outside. So this antenna you can pull to 1.2 meter long, and this is an M4 screw, so instead of using the wires, I can just hook up this antenna as my outdoor testing antenna. So that's why I always use M4 screws. You may want to use different screws depending on what type of antenna you're using. But here's what I'm going to use. So this is an M4 screw going into an M3.5 hole. So we may need a little bit of force here. I take the screw to do the work. The other component we need to mount is these screws for the antennas. They are the M4 screws because I want to use this antenna, telescopic antenna, when I'm testing outdoor. They can be expanded to 1.2 meter long, and they are using the M4 screw holes. So if you have other type of antenna that you want to use, you can use other type of screws, M3 or M5, up to you. And this nut is very handy. When you need to insert a wire, you can put it in and secure it like that. And the holes in the board is designed for M3.5. So if you have an M4 screw mounted, it will be secured properly. Otherwise, you can always fasten the screw here, fasten the nuts here to secure it in place. Okay, rest is to do the soldering. I'll move the soldering faster, so you don't need to wait that long. Just follow the circuit diagram in my blog to do the wiring. Next, I'm going to do some indoor testing with the big loop antenna, which is 1 meter wide in diameter, hanging by my window. I It's enough to do this type of testing using the loop antenna. Just connect one end of the loop coil in the antenna as the antenna input of your crystal radio, and then the other end just connect it to the ground input terminal of your crystal radio. Let me swap out the diode and replace with a 3D cube. You'll find the performance will be much better.
好多過去嘅經驗咧都係負面嘅，佢好多嘅自動化思維啊，即係你一出現呢個情況，佢就會自己諗，唉，每個人都好憎我，係冇人中意我㗎。定係其實你真係做法可以修正少少，令到人哋更加中意你。你要檢驗下究竟係邊種方式。有咗手機係一件好事，又係一件壞事。我
雖然話我哋好多僵屍粉喺嗰度，但係有時如果你用得好嘅話，都可以降低孤獨感同抑鬱嘅心境，係嘛？
係啊，有時我會覺得。
That's the last part of my video. Thanks a lot for watching. Click my link to see more details in my blog and post. Share, like, and subscribe. Thanks a lot for watching. Bye now.